Unit 7, Circles, Lesson 6, Special Segments in a Circle. Your objective for this lesson is to apply properties of intersecting chords, secants, and tangents to solve problems. Okay, if two chords intersect in a circle, then the products of the lengths of the chord segments are equal. So you can say, and it's written right here for you, if we've labeled the different parts of the chord A, B, C, D, A times B equals C times D. Okay, so A and B go together because they're on the same chord, and C and D go together because they're on the same chord. Okay, so same chord, same side of the equation. Example 1, find X. Well, you see we have two intersecting chords, which tells me that I can multiply the two products, so 3 times 8, and set them equal 6 times X. 3 times 8 is 24. So I can divide by 6, and X is 4. Three segments. The secant segment. So a secant segment is a segment of a secant line that has exactly one endpoint on the circle. An external secant segment is a secant segment that lies in the exterior of the circle. And a tangent segment is a segment of a tangent with one endpoint on the circle. You can see here that if two segments are drawn to a circle from an exterior point, such as here, so we have two segments drawn from our exterior point A, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant segment and its external secant segment. So we can see here AC and AE are secant segments. So that's this line and this line. Those are secant segments because it's part of a secant line and you have one endpoint on the circle. So C is on the circle, E is on the circle. AB and AD are external secant segments. So AB here and AD, external secant segments because again they're part of a secant line, but that endpoint is on the circle and then it goes outside the circle to point A. So this is saying that AC, so the big segment, times AB, the external part, equals AE times AD. Okay. If a tangent segment and a secant segment are drawn to a circle from an exterior point, again A is our exterior point, then the square of the measure of the tangent segment, so that's AB is our tangent segment, because B is the point of tangency, is equal to the product of the measures of the secant segment, which would be DA, or AD, and its external secant segment, which is AC. In other words, in this diagram, AB squared equals AD times AC. Example 2. AB is a tangent to the circle. Find X and round to the nearest tenth, so this is 1 decimal place. Okay, so we have a tangent segment and we have a secant segment. In this case, remember the tangent segment squared, so 18 squared, equals the secant segment, which is the whole thing, dB. So that would be x plus 15. So we have two parts. Add them together to get the whole thing. So x plus 15 times the external secant segment. So times 15. So the first thing I need to do is figure out what 18 squared is. 18 squared is 324. So 324 equals, this part needs to be simplified. So I can distribute the 15 into the parentheses. Both terms need to get multiplied by this outside 15. So I have 15x plus 15 times 15 is 225. Now I need to subtract 225 from both sides. Let's see what we get. Let's double check first that I got 15 times 15 right. Yes, we did. Okay, 225. So 324 minus 225 is 99. So 99 equals 15x. Now we're going to divide by 15 to get x by itself. So 99 divided by 15 gives me 6.6. So really I didn't even have to round that. It's an exact answer. Okay, so x is 6.6. And that's what we're looking for, so I'm going to circle it. Okay, that was our last example for this lesson. But I would suggest going back and maybe rewatching this because there's a lot of information. This is a short video, but there's a lot of information. Other than that, that's it for Unit 7, Lesson 6.